Okay, these are radical equations. Radical equations are equations that have radicals in them. In order to get rid of a radical, you would have to square the square root. That will cancel it out. But to do that, we actually have to isolate. Our goal is to isolate x first. So just pretend as if the radical wasn't even here. In example 1, ignore this piece, right? We have to get rid of that division by 2 first. So I'll multiply both sides by 2. We get 32 equals the square root of x. In order to get rid of the square root of x, you would square it. They're inverse operations, so those cancel, and then you do the same thing to the other side. You square that. So 32 squared equals x, but we actually have to calculate 32 squared, which is 1024 equals x, or x equals 1024. And you can even check your work. Plug that in to the square root of 1024, which is 32, and then divide it by 2, and you would get 16. Okay, in example 2, so same thing. We need to isolate x, which is right here, but it's all underneath the square root, so I'm going to ignore that for a second, and I have to get rid of that plus 2. So we'll subtract 2 from both sides. So I have radical or square root of 4x minus 7 is equal to 5. Now I'm stuck at that square root, so to get rid of the square root, I'm going to square it. That canceled the square root, and so I have 4x minus 7 is equal to 5 squared, which is 25. And then to isolate x, like a regular two-step equation, x is right here. Oops, that looks like a plus now, so I'm going to get rid of that. So I would add 7 to both sides, and 4x equals 32. Divide both sides by 4, and x equals 8. So again, we can plug that into the original equation, which was square root of 4 times 8 is 32 minus 7 plus 2 equals 7. So the square root of 32 minus 7 is radical 25, which is 5, plus 2 equals 7. So we know we have that correct. Actually, okay, there are times when it can get a little bit more challenging. So again, I see that I'm solving for x, but I have x on both sides. I can't just subtract x and then put it into the square root. It doesn't work that way. But what I can do is I can get rid of this square root. Let's make things a little bit simpler here. So let's get rid of the square root. We'll square both sides. Remember, it's this whole group squared, which doesn't mean x squared minus 9 or x squared plus 9. It has to be FOIL right here. It's x minus 3 times x minus 3. That's what x minus 3 squared means. So I'm going to have to end up foiling this. And on the left, I was left with x plus 3. So now I have x plus 3 equals, let's FOIL. Well, x times x is x squared. Outer would be negative 3x. Inner is also negative 3x. And last would become positive 9. So let me simplify. X squared, this combines to negative 6x plus 9. And I see that I have a quadratic equation here. So I'm going to go ahead and get everything to this right side. So I'm going to move the x. And I'm also going to end up needing to subtract 3. If it doesn't confuse you, you can do both at the same time. That was to cancel both of those. So I have 0 equals x squared minus 7x plus 6. So now from there, I do have a quadratic equation. We have a couple of options. I can go through and do the quadratic formula where a is 1, b is negative 7, and c is 6. And I'm going to use negative b plus or minus the square root of b squared minus 4ac all over 2a. That's one way. I'll go ahead and do that. So negative b would become positive 7 plus or minus the square root of b squared, which is going to be negative 7 times negative 7 is 49, minus 4 times a, which is 1, times c is 6, all over 2a, 2 times 1. This becomes 7 plus or minus the square root of 49 minus 24, all over 2. And 49 minus 24 is 25. So the square root of 25 is going to become 5. So that means that I have 7 plus or minus 5 all over 2. That plus or minus means I'm going to write two problems. 7 plus 5 over 2 and 7 minus 5 over 2. So this one equals 12 divided by 2, which is 6, and this is 2 divided by 2, which is 1. So my answers are 6 and 1. So x equals 6 and 1. That's my answer. Now I can do this another way. I could factor. since it's a quadratic equation where a is 1, this is by factoring, and in red that was by the quadratic formula. So by factoring, when a is 1, I need two things that multiply to 6 that add to -7. Put x and x here. Two things that multiply to 6. Well, I've got 1 and 6 or 2 and 3, but they have to add to -7. So if I do -1 and -6, that works. And remember, to solve, this is zero product property. To solve, you have set each one equal to 0. So x minus 1 equals 0, and x minus 6 equals 0. Solve each of these. So plus 1, so this one would be x equals 1. And then solve this, plus 6, and x equals 6. Same answer, 1 and 6. So you can use whichever method that you would find most helpful. Now we need to check that both of these actually work. So let's plug them in. So 1 and 6. So let's start with 1. So radical 1 plus 3 equals 1 minus 3. So let's double check. Well, 1 plus 3 is 4. The square root of 4 is 2. And 1 minus 3 is -2. So 1 actually didn't work. That one's no good. Let's try 6. So radical 6 plus 3, which is going to be 9. And on the right, it would be 6 minus 3. Well, radical 6 plus 3 is 9. Square root of 9 is 3. And 6 minus 3 is 3. So this one works. So the only real answer then is x equals 6.